All right, this is video number 3 from section 1 of chapter 7. We have one more sex-linked trait that we need to deal with, another variation on that. So we're going to go take care of that right now. This example is also very common, just like the color blindness. I think all of us in here have seen a calico cat before, and that calico trait is pretty unique. Right? So this is X chromosome inactivation that we're talking about. Since you realize that females have two X's, and they don't really need two X's because a boy only has one, and he's doing perfectly fine. Right? What's going to happen here is one of those X's in every cell is going to be turned off because you don't want to double express these alleles, these genes. So generally speaking, in any given cell, only one X is active at any given time. Right, which brings us to the bottom down here. There's actually inactive X chromosomes that you can actually see if you look at a cell for a girl underneath a microscope. You can see this inactive X that stays condensed and is never read because you don't need it. So again, this example is kind of unique. Again, for a cross, I'm going to need a boy and a girl. And in this example, I'm going to cross an orange male with a calico female. Right? So there's really only 3 options here. It can be orange, black, or calico. And basically, calico comes from that heterozygous version of this trait. Right? The male is either orange or black because the male only has one X chromosome. The male will only have one allele that could lead to that color of its fur. So this male that we're dealing with here happens to have that orange allele, right? Said he's going to be an orange male, so there you go. Put a little O, that's for the orange. Whereas the female is calico. Now, just in case you haven't seen a calico cats are orange and black, kind of modeled throughout that fur coat, right? Yes, calico cats and other cats may also have white paws or white bellies, or their tail can be kind of white, but that's actually a completely different thing, and we're going to try not to confuse you too much here. But I'm crossing an orange male with a calico female. So the calico is going to have one orange allele and one black allele. Now I'm using different letters because it's actually kind of convenient in this case. If I use 2 O's and I use a lowercase o, I really can't tell the difference between that and the uppercase one. So I just picked O and B. So she's got one orange allele and one black allele. I'm going to do the cross and look at all the different possible combinations. And I'm going to interpret those. I'm crunched for space here, apparently. I think the Y doesn't take very much room. And again, just like before when we talked about these sex-linked traits, that Y doesn't actually matter. It doesn't affect the color of the coat at all, one way or the other. So we had that orange male, and I'm going to use orange since I can. That kind of makes sense. And I have a calico female. That's the mom, right? One orange, one black, actually, allele. So she's orange and black. But my different possible offspring are going to be a little bit weird this time. All right, let's take care of the girls first. The first girl, top left, fairly simple. The only allele that she has is an orange allele. She has 2 of them, but they're both the same. So she's going to be orange. That cat, that offspring would be orange, definitely. Whereas the other girl has an orange allele and a black allele. Now again, what makes that calico possible is that you have that X chromosome inactivation. Not both X's are used at any given time. And because orange and black, in this case, one is not actually favorable over the other, it doesn't really matter which one's being shown. In the case of color blindness, it was to your advantage to have the normal allele allele as opposed to being colorblind. So when those situations occur, that X chromosome inactivation, it might be the same allele that's inactivated every time, right? Because you don't really want to be colorblind, whereas in this case, it doesn't really matter. So for that female cat, since she has a black allele and an orange allele, and it just randomly gets shut off one or the other throughout her skin, those follicles that she has that are producing this hair, that protein that comes from your DNA, right, it's completely random. Some of the follicles are going to produce black hair, some of them are going to produce orange hair, and it really doesn't matter which one's which. So that's where that calico comes from. She's actually expressing both alleles simultaneously. Whereas again, for boys, you can't do that. You only have one allele. It is actually technically possible to get a calico male, but it's really, really rare because that calico male would have to have 2 X chromosomes, and that is not normal, not even a little bit. So being XXY would be a little strange. In this case, though, those possible offspring that we're showing here, right, one of those males, top right, would be orange. The other one would likely be black, and that's it. So this one's a little bit different than everything we talked about before because there is no dominant, there is no recessive. It doesn't matter which allele is being expressed in any way, shape, or form, and it's completely random as to which one's going to be active and which one's not going to be active. Again, you can actually tell the difference between a female cell and a male cell if you look at it because there should be that bar body, that inactive X chromosome that's condensed and not being used. But otherwise, it works for this example. So those of you that have cats at home, there you go. You explained something.